In section 2.7, we're going to prove some angle pair relationships, dealing with some of the angle pairs that we talked about last chapter and some new theorems that go along with these. First theorem is pretty profound. This is labeled as 2.3, but it's called right angles congruence theorem. If you're ever going to use this theorem in a proof, you would write down right angles congruence theorem as your reason. What it says is that all right angles are congruent. What you're saying, well, obviously, yes, all right angles are congruent. And a proof of this would be very simple. If I knew angles 1 and 2 were right angles, I would say they both measure 90 degrees. Therefore, they'd have to be equal or congruent to each other, since they were both 90 degrees by transitive property, because two things are congruent to the same thing, they're congruent to each other. But if you ever have two right angles in a proof and you need to say they're congruent, right angles congruence theorem, we're going to see that right here. Write a proof given these two things. I hope you remember this symbol. This says that K is perpendicular to M. That means line K is perpendicular to line M. Also, line K is perpendicular to line N. And I want to prove angles 1 and 2 are congruent. So hopefully you're thinking something along the lines of, I know what perpendicular means and what that implies about angles 1 and 2. You should be thinking, I know what kind of angles 1 and 2 are, and then we're going to use right angles congruence theorem that we just talked about. So, statements and reasons for my 2-column proof. I start out with my given. K was perpendicular to M, and K was perpendicular to N. So we had two givens, we had two lines that were perpendicular. Okay, well, what does that mean? If line K is perpendicular to line M, what do you know about angle 1? Angle 1 is a right angle. And if line K is perpendicular to line N, then angle 2 is a right angle. So I'm going to say angle 1 and angle 2 are right angles. The question is, how do we know that? Well, don't we know that because of the fact that they told us the lines are perpendicular? So really, I'm getting it from this symbol, which is perpendicular, so I'm getting it from the word perpendicular. That's the definition of perpendicular then. Remember that anytime you're getting something from a word, it's probably the definition of that word. Like here, it's a definition of perpendicular. Perpendicular lines meet or cross or intersect at a right angle. That's how I knew angle 1 and 2 were right angles. And now, what did we just find out about right angles? All right angles are congruent by right angles congruence theorem. Look, right angles congruent. Basically, we're saying that right in the statement. So, I wanted to prove angles 1 and 2 are congruent. I just have. Angle 1 is congruent to angle 2 because they're both right angles, and I know that right angles are congruent by that theorem we just talked about, right angles congruence theorem. And the only thing I'm going to abbreviate here is theorem, which you can always do as THM. Okay? So we use definition of perpendicular in this one, and the fact that right angles are congruent by right angles congruence theorem. Alright, these two theorems sound really complex, but when you understand them, they're not too bad. We have congruent supplements theorem and congruent complements theorem. First thing you have to remember is what the word supplements means and what the word complements means. Congruent supplements theorem says if two angles are supplemented to the same angle, then they are congruent. Or if two angles are supplementary to congruent angles, then they are congruent. Congruent complements theorem says a similar thing except dealing with two angles being complementary to the same angle, then they are congruent. And I have a little statement in the middle kind of to help explain this. Now, you have to remember that what the word supplementary means. If two angles are supplementary, remember that that means that they add to 180 degrees. Okay, supplementary, they add to 180 degrees. Remember that complementary means that they add to 90 degrees. Let's try to decipher this congruent supplements theorem here. If two angles are supplementary to the same angle, two angles supplementary to the same angle, then they are congruent. What this means, if I knew that angles 1 and 2 were supplementary, and I knew that angles 3 and 2 were supplementary, and I need you to notice something here. Angle 2 is in both of these. So really, two angles supplementary to the same angle, 1 and 3 are both supplementary to the same angle because they're both supplementary with angle 2. So I want to think about what this means here. If 1 and 2 are supplementary, that means they add to 180. I don't know. Let's just give an example. Let's say angle 1 was 60 degrees. Angle 2 then would have to be 120 because, again, they have to add to 180. Well, we just said angle 2 is 120. So angle 2 over here is still 120. Well, what does that mean for angle 3? Because if 1 and 2 are supplementary and 3 and 2 are supplementary, that means these two have to also add to 180. So angle 3 would have to be 60 as well. At this point, you notice, look at this. Angle 3 and angle 1 had to be congruent. They had to be the same measure because they were both supplementary to angle 2. And angle 2's measure can't change. So yeah, two angles were supplementary to the same angle. Angles 1 and 3 were both supplementary to angle 2. And if they both add to 180 with angle 2, whatever angle 2 is, that means the other angles, in this case 1 and 3, would have to be the same number. So the conclusion is that those angles that were supplementary to the same thing are congruent. In this case, angle 1 had to be congruent to angle 3. Okay, trying to decipher what that means. Congruent complements theorem says if two angles are complementary to the same angle or two congruent angles, then they are congruent. Meaning, complementary is angles that add to 90. If you have two angles that add to 90 with the same angle, let's say you have two angles that add to 90 with this angle measure of 40. Well, they'd both have to be 50 then, wouldn't they? So then they have to be congruent. So congruent supplements theorem and congruent complements theorem. Let's look at those a little more in depth. And actually, we're going to prove this theorem, meaning we're not going to use the theorem, we're going to prove it. Where did it come from? If it's a theorem, it's something that can be proven. So at some point, someone proved these things, and now we have these theorems. Well, why does this work? I'm given that angles 3 and 4 are supplements. I'm given that angles 5 and 4 are supplements. I want to prove angle 3 is congruent to angle 5. Think about what our theorem just said. If we have two angles, 3 and 5, supplementary to the same angle, look, they're both supplementary with angle 4, then I know that those angles, 3 and 5, are congruent. So I am proving this theorem and showing why it is a legit theorem. So, statements and reasons here. As always, start out with what I am given, which are these two statements. Angle 3 and angle 4 are supplementary. Angle 5 and angle 4 are supplementary as well. Whew, a lot of writing just for that given. Okay, I don't even necessarily need a picture here because I'm going to be going off of this definition. What does it mean if angles 3 and 4 are supplementary? You know that supplementary angles do what? They add to 180. So if 3 and 4 are supplementary, I know that angle 3 plus angle 4, you know what? That's wrong if I write it that way. If I'm talking about the number associated with angle 3, I need to use measure. So measure of angle 3 plus a measure of angle 4 has to equal 180 degrees. Also, if I know 5 and 4 are supplementary, I know that doing measure of angle 5 plus a measure of angle 4 is also 180 degrees. Now, what's the reason for this? How do I know that they add to 180? Based on this word, supplementary. Anytime you're going off of a word, it must be the definition of that word. And in this case, it is the definition of supplementary angles. Okay. Now remember how we're trying to prove angles 3 and 5 are congruent? Well, look, 3 and 4 add to 180, 5 and 4 add to 180. Now, if both of these things equal 180, then I could put 5 plus 4 here for 180, or if both of these things equal 180, then they have to be equal to each other. So I know that the measure of angle 3 plus the measure of angle 4 would have to be the same as the measure of angle 5 plus the measure of angle 4 because they both were equal to 180, so they're equal to each other. Now the property that says two things equal to the same thing or equal to each other is transitive property. Remember, that's kind of like the chain rule. You could also be saying instead of 180, I put in like measure of angle 5 plus measure of angle 4. So you could put substitution. Either of these reasons is okay. At this point, remember, we want 3 and 5 to be congruent. Well, here's 3 and 5. Look what's on both sides. Measure of angle 4. Is there a way to get rid of measure of angle 4 on both sides? And yes, there is, because it's being added on both sides. If I subtract measure of angle 4 from both sides, I'll be left with, if I get rid of measure of angle 4, I subtract it. On this side, I just have measure of angle 3. I subtract it here, it goes away. On the right side, I just have measure of angle 5. I subtracted measure of angle 4 from both sides, which I know I can do by subtraction, property of equality. And finally, remember how I wanted 3 and 5 congruent? Not their measures equal, but the angles congruent. And I know I can go from numbers being equal in angle measurements to those angles themselves being congruent because of the definition of congruent, or definition of congruency. So I just proved why the congruent supplements theorem is an actual theorem, why it's legit. Because I know supplementary means things add to 180, and if we have two angles adding with the same angle to 180, I can basically get rid of that angle. And know that those angles are congruent. Alright. Dealing with linear pairs and vertical angles, which are very much related here. We have linear pair postulate. Remember that postulates cannot be proven. They're more of a common sense thing. What linear pair postulate tells us is that if two angles form a linear pair, then they are supplementary. Meaning, if we have a linear pair, that means we have two angles together on a line. Like here, I have angles 1 and 2 forming a linear pair. Together, they must form a line, which you know means these would add up to 180, which is what supplementary tells us. So two angles are together on a line. Yes, they are supplementary because they add to 180. Kind of makes sense, which is why it's a postulate. But from that, actually using linear pair postulate, we're going to see in the next proof that we can prove this theorem, which is vertical angles congruence theorem. Now you know that vertical angles are congruent. We've already talked about this. This is an actual theorem. This is something that is able to be proved, that vertical angles are congruent. And actually after today, you're going to be able to use vertical angles congruence theorem anytime that you need to say, hey, these are vertical angles and I know they're congruent. Okay. Now what I'm going to do is actually prove this theorem. I'm going to prove why vertical angles have to be congruent only using linear pair postulate in this next example. So I'm given angle 1 and 2 are vertical angles. By definition, vertical angles are across from each other when two lines intersect, and I want to prove that vertical angles really are congruent. I'm proving theorem 2.6. Okay, just like I said, we're going to prove why vertical angles have to be congruent. I'm pretending I don't know that right now, even though of course I do. So my statements and reasons. I start out with my given. Angle 1 and angle 2 are vertical angles. I'm going to do angle apostrophe s there. And step 1, you start with what's given. Alright, there's got to be something else from the picture, because right now I'm pretending I don't know that vertical angles are congruent. I'm trying to prove that they are. Why would 1 and 2 have to be congruent? You notice in the picture I have labeled an angle 3. And that will come into play here. What other special types of angle pairs do you see in this picture? For instance, what would you call angles 1 and 3? They're next to each other on a line, right? Aren't they a linear pair? And what kind of special angle pair are angles 2 and 3? Aren't those together on a line, so another linear pair? So that's what I'm going to write here, is that angle 1 and angle 3 are a linear pair. And I'm going to put a little semicolon because also I know that angle 1 and 3 are a linear pair, so are 2 and 3. And the question is, how do I know that? I'm really very dependent on the picture for this. So it is given in the diagram that they are a linear pair. But it's also kind of by the definition of a linear pair. Because I know that a linear pair has to be next to each other on a line. So I'm going to put both of those things. And from there, I'm going to use what I just talked about. We had a postulate about linear pairs. If two angles form a linear pair, then they are supplementary. Oh, okay, so the angles that I just listed as linear pairs are also supplementary. So in this next step, since angles 1 and 3 are a linear pair, I could say angle 1 and angle 3 are supplementary. Linear pair postulate just told me that if you have a linear pair, they are supplementary. And then also angles 2 and 3 would be supplementary as well. And the cool thing is I'm going to use my other theorem that I just listed in the next step. But I knew that linear pairs were supplementary by linear pair postulate. That linear pairs are supplementary. Now the question is, can I say that angles 1 and 2 are congruent? Look at this. 1 and 2 are both supplementary with angle 3. Now we just had a theorem that said if two angles are supplementary to the same angle, then they are congruent. I know I have 3 and 4? Or no, excuse me, I have 1 and 2 both supplementary with 3. Just like here I had 1 and 3 both supplementary with 2. So I can use congruent supplements theorem. In this case, I do have two angles supplementary to the same angle. Look, these two angles are both supplementary with angle 3, so therefore they are congruent. And I can say that angles 1 and 2 have to be congruent, that these vertical angles are congruent based on that congruent supplements theorem. They were both supplementary to the same angle, therefore they are congruent. And this is an example of when congruent supplements theorem would be used. So kind of cool, we're using things with supplementary and complementary angles, linear pairs, and vertical angles, and right angles today.